Greetings, programs. Welcome to Stegosaurus Studios. I'm Mike, out here in the shop with Dummy again. So some updates on where the project stands. So in the last episode, I was talking about new new design for the front based on what Malcolm, the feedback he provided. So I'll show what that design looks like. And then I was talking about incorporating the air springs in the rear, and I'll show you on Infusion what that looks like as well. And then we will talk about how I messed more things up, because, you know, that's what it's all about, messing things up and then figuring it out and then moving forward. And then at last I will talk about the where we stand as far as actually ordering hardware and that sort of stuff. So anyway, I'm out in the shop right now, but I'll head inside and record the video in front of the computer and then come back out here for the wrap up. All right, so see you in a bit. Okay, so here we are in Fusion in the house. This is the overall design. So let me talk about the front first. So zoom in a little bit. So the previous design had basically the wheel carriage sliding up and down, 4 sliders, one on each corner, the whole thing sliding up and down, and which, as Malcolm suggested, could get twisted in there. So he actually drew up something similar to this. This is much more refined, but it's what he calls a trailing arm system. So basically you've got the wheel assembly attached to 4 arms, 1, 2, 3, and then the other one's back here, 4. This makes a trapezoid. So as this moves up and down, because of mechanics, the wheel remains flat as it moves up and down. And then this is the air spring right here. So as this wheel moves up and down, it stays straight up and down. You'll see this is the shaft here. I haven't specified the motor and I'm actually want to get this built and then put a torque wrench on this and put it on the roughest surface it's going to see, and then try and turn it and get a torque measurement, because I don't have a good sense of how much torque is going to be required to turn this. So anyway, this here you can see the arms, and that moves up and down. So that is the front. And then on the back, so I've now incorporated the air springs on the back. Back when this here was a mountain bike shock, it basically connected up here, similar to the way the air spring does, and then connected to the arm down here. What I've done is I've actually created, in automotive terms, this is a double wishbone suspension. So there's one wishbone. There's the second wishbone. This is the kingpin. So the kingpin axle goes through these 2 ball joints here. So again, as this wishbone moves up and down, as this wheel moves up and down, it stays straight up and down because of this geometry. And then, you know, again, here is the air spring with the ability to increase 4 inches. So when it inflates, it will essentially push down, which will move the wheel down, in essence, raising the whole frame up. So, so that is the biggest change, is this double wishbone suspension, and then the 2 ball valves here. So one other thing that I talked about in the last episode was this problem with the steering arm. So this is the rack, this is the pinion, so the rack and pinion steering. Ball joint, tie rod, ball joint connected to the steering arm that moves the wheel. And in the previous version of this, I had this straight. I had this steering arm come out and then go straight. And what would happen, which I showed in the model, is as the wheel tried to move up, there was nowhere for this to go, and it would induce turning motion. So now basically the rest condition is this is at an angle. Instead of coming straight out, it's at an angle. So then when the wheel moves up, hits a bump or whatever, this ball joint has, and this one, they have a place to go. They're not trying to move a solid rod. It can bend while it moves up. So that is how I fixed that problem. Now, when I was out in the shop, I did mention that I screwed something up. So in my brain, when this rack moved, this would clear this corner here. So what I have set up, I have all the joints set up in here, and this wheel is constrained. It can move 45 degrees in either direction. So 45 one way, 45 the other way. So move it this way, and it actually just hits the corner of the frame over here. So that's fixable just by, you could just essentially cut that frame off at a 45-degree angle and it would be fine. However, come on, this thing doesn't want to move here. Sorry for this. Okay, this will work. So we move it the other direction and it hits way worse. So basically the ball valve and the steering arm are interfering with this right here. I don't have a lot of space to shift these armatures and shift the air spring further this way to clear. And the further I shift it in, the harder it's going to be for this to operate correctly. So I'm recording this on a Saturday, and 8020.net's they're not open for calls today. At least I don't think so. I'm going to call them on Monday. Basically, I want to turn this 90-degree angle here into a 45-degree. So basically, this will come over like this, and this will clear. I may need to extend. So this is an aluminum block that the ball valve, or the inline ball valve, or not valve, inline ball joint connects into. I might extend this aluminum block out a little bit, which will get a greater angle to better clear like right in this area. But I'm hoping that 8020 has done 45-degree angles. I know they have a 45-degree angle brace. I'm just going to have a conversation with them and show them this picture and see what can be done. So it's not horrible. So I think with the 45, I should be able to fix that problem pretty easily. So that's the overall design. So one rack and pinion system here, the other one over on the other side for the right wheel. Same issue over there. The wheels are already put together, the front. So once I get stuff ordered, I'll start putting this together. So that's it in Fusion. Okay, back out here in the shop. So we saw all the stuff in Fusion. So once I figure out this problem with the crash on the rear suspension, the rear steering, the bill of materials is complete, other than whatever has to be changed for this to fix this. And then I just need to basically start placing orders. So the McMaster car order will be really easy because it's just off of I have the bill of materials in Excel, and just load everything off Excel and enter it all in. Easy order with Rev Robotics for a couple of things. A little bit more work on the send cut send orders because I got to export from Fusion. There's like four or five. I can't remember how many things. Send cut send is going to be the vendor for that. And then the last order and the most difficult is the order with 8020.net. That's all the aluminum extrusion. So in the Excel spreadsheet, I just have of each of the individual members and its length. But 8020 they charge for every cut. It's I don't know what it's like $5, $8. I don't know. It's something like that. So I want to minimize the number of cuts. I have a bandsaw, which should be able to cut this aluminum extrusion. So I need to combine these structural members together and then give a little extra for cutting. So as part of putting that order together, I'll need to be combining line items together to minimize the number of cuts. And there are some members that need custom machining from 8020. I'm using some internal, I forget what they call them, they're cam fasteners because they're really strong. But those, I don't feel confident that I can do the machining myself, so I'll have them do it. So those ones can't be combined because, if they've got a custom machining on both ends, you can't combine it. There has to be that length. So anyway, so that's the status. So with any luck, the next episode after this one will actually be hardware. And actually, there's a few things that I can get to work on right now with some of the parts I have. For example, I need to drill a couple more holes in this plate to mount some things. So I can get to work on that, and I'll be recording all that stuff as well. So anyway, thanks for tuning in, and I'll see you next time.